Yes, it is the continuation of the class number 32. It is today's class is on thermodynamics, and today specifically higher secondary first year. Specifically, I am going to touch upon second law of thermodynamics, entropy and spontaneity. And the spontaneity and entropy are the very important topic for entrance as well as of a state and board or CBS exam point of view. And also a lot of questions are always asked in various entrance exam. Please minutely follow the class. Let me start. So let me start with the first point, specific heat capacity. So let me define. You can understand it. The term is a bit critical. You may not be practically understand what the fact is. The specific heat capacity of a substance is defined as the amount of heat required to raise the temperature of 1 gram of substance to 1 degree centigrade, and it is designated by either Cp or Cv when the process of raising the temperature of the substance by 1 degree, 1 gram of the substance by 1 degree at constant pressure, it is called Cp. When this process is done at constant volume, it is called Cv. So in your book it is very nicely derived Cp minus Cv. I am not going to details of this one. Please go through this one. The relation of Cp minus Cv is equal to R, where R is equal to gas constant, the value R is equal to 8.314 joule per mole, or it is equal to 2 kel or 0.082. Lots of values are there. Here we will assume the calorie value, 2 calorie. So Cp minus Cv, that is Cp is equal to 2 plus Cv, that is Cp is greater than Cv. That the two process, one is at constant pressure, other is at constant volume. When the substance amount of temperature is required for 1 mole of the substance to raise the temperature by 1 degree centigrade, in this process the Cp is greater than by Cv. Am I right? So you just keep it in your mind. My main point today is to describe the term molar heat capacities. I am not defining what is molar. It is designated by gamma. It is the ratio of Cp by Cv. It is called molar heat. It is the ratio of Cp by Cv is equal to molar heat capacity, and is designated by gamma, and gamma is equal to Cp by Cv. For your understanding, for time being, at your level, the value of Cp and Cv are not given. You please keep it in your mind. Cv is equal to 3 by 2 R, and Cp is equal to 3 by 2 5 by 2 R. The 2 unit of above factor is more than this. Am I right? Just above 2 you increase. If Cv is equal to 3 by 2, then Cp is equal to 5 by 2. How it is arrived, I will not define, and it is for internal energy is equal to 3 by 2 RT. From this it has derived. I will not show it here at this point. It will be clumsy at this point of view. So you just keep it in your mind. But one thing, this is fixed value, but if it is for monoatomic, am I right? If the atom is monoatomic, then this, and if it is polyatomic, so you do one thing, you adopt some term. If it is diatomic, then value of x equal to 1. If it is tri, the value of x equal to if it is tri, value of x is equal to 2. Just to add up, you will get the value. Am I right? So simple value, monoatomic value 3 by 2 R, and for monoatomic atom Cp is equal to 5 by 2, and if it is polyatomic, say diatomic, so you place here 1. So first you find out Cb. Whatever answer means, if it is 1, the answer will be 2 1 2, that is 5 by 2 R, and your Cp will be 7 by 2 r. You just add up 2. Am I right? So in entrance, what type of question very often asked is, find the value of gamma. What is the gamma for monoatomic? Answer: Cp by Cb is equal to 3 by 2 r is equal to 5 by 2 r. 5 by 2 r you cancels out. I think it will get to 6 and C. Sometimes it is asked for diatomic molecules, find the value of gamma Cp Cb. Then you add up is 1 5 by 2. This is equal to 5 by 2 and this is equal to 7 by 2 and r will cancels out. I think it is 1.4. For triatomic, you calculate, you will get it 1.3. So the point number, specific heat and gamma is over. Now I am going to solve out work done in reversible process. So in my earlier classes, I have already explained what is reversible process, what is isothermal process, what is adiabatic process. I have already explained, so I don't find it important here to mention what is reversible process. Also, in my last class, I told you W is equal to P del B, or we can write W equal to P del B in this way. Well, we will integrate and we'll use calculus, we will write W equal to P del B. Am I right? So, work done in reversible process, we will write W is equal to P del B, where P is the pressure and del B is the change of volume, and where this small d is used, this means it is an very infinitesimal small change in volume. And when this del, capital del is used, means it is measurable volume from some 2 ml or 2 liter to 5 liter, 5 liter to 7 liters is some measurable volume. Am I right? So here we will just explain work done in reversible process. We will write W is equal to P into del B, work equal to actually P into B. From this, when the change in volume is very small dB, when change in volume is measurable, is capital del B. Am I right? So if you want to get total work is obtained by integration of P del B to finite volume, say B1 to, for W is equal to integration B1 B2 into P into dB. Sorry, we know PB is equal to nRT, therefore P is equal to nRT by V. For time being, we will not use here n is the number of mole. We will write P is equal to RT by B. It is ideal gas equation. PB is equal to nRT. For 1 mole, it will be PV is equal to RT. We have assumed 1 mole of gas. So here B1, B2 is equal to RT by V into dB. We will take this term out, RT integration B1 B2 dB by V. So we know integration dx by x equal to ln x or log x. So applying this principle, RT is equal to ln, and if you put the value B1 B2, so it is ln 2.303 RT, then ln become log B1 by B2. So for reversible process, W reverse is equal to 2.303 RT log B1, sorry, this should be B2 minus B1, B2 is the above value, and B1 is the below value. So ln B2 by B1, ln B2 by B1. So we get B2 by B1. So this is the expression. Very often problems appears or asked in the question in the exam. So you should use for W reversible equal to 2.303 RT log B2 by B1. And if number of mole of the gases is given, just you add here N RT log B2 by B1. Am I right? You add N. So this is the expression for work done in reversible process. Expansion of gas in vacuum when P external means external pressure is equal to 0. This is called free expansion. Expansion gas in vacuum means from this volume to that volume. Say this is vacuum and this is a sealed container. Gas molecule is here. If you allow to pass this gas molecule to pass into this chamber, so gas expand in when it reaches this volume, and that is called free expansion, where no external pressure act upon this. That pressure, external pressure is applying here, and due to this external pressure, this gas is passing from this chamber to this. Without any external pressure, the gas will, a bit later we will tell, it is a spontaneous process without any work being done on the system. The process will occur. So since there is no external pressure, when gas passes from one chamber to another vacuum chamber, it is called free expansion. So free expansion from first law, earlier I have in a class I have written E, but in your book it is U. So you write U is equal to first law of thermodynamics, Q minus W. Work has been done by the system. So next part is, if it is on the system plus work is done by the system, if you apply something upon this one and gas passes, it is on the system, then work is plus. And if work is done by the system, system is self spontaneously changes from this to this, it is called by the system. That's why Q plus W has become Q minus W. Don't be confused with this sign. Isotherm means there is temperature constant. Am I right? There is no change in temperature. Q is equal to 0. Del U is equal to 0. So when this is isothermal, you are getting therm in temperature. Temperature is constant. When there is no change in temperature, internal heat content remain the same. So for the two system there is no change in Q. So Q equal to 0, or when there is no application of temperature, so the heat content of single system does not change, means Q remains same, and internal energy also remain intact, because internal energy is all type energy. In the last class I told you. So there is no question of increase of internal energy when delta is constant. So for isothermal process, delta is equal to constant, Q is equal to 0, del is equal to 0. Very often small question asked, which of the following quantity is equal to 0 or this equal to that in the isothermal isothermal process. This is this. Am I right? So for isothermal process, again let me explain. U is equal to first law of thermodynamics, Q. So what is the isothermal reversible change? If In the system, isothermal free expansion is going on and the process is isothermal reversible change, then we will write Q is equal del E is equal to Q plus W, and for this system del U is equal to 0, so Q plus W, so we know Q is equal to minus W. So this is the shortcut of isothermal reversible change. Now if you make it isothermal irreversible, isothermal irreversible change, irreversible change. Now what's happened? W, what is W? P into del V. And when it is irreversible change and there is free expansion, the equation of free expansion is there. So in the process del U is equal to 0, putting del U in the first law, we get Q is equal to minus E and P is equal to W is equal to work done is equal to P del B. It is known to us. Then this pressure is called P external into what is change in volume? Volume final by minus volume initial is the change of volume. And this is a very important relation, very often question asked. At constant pressure or at external pressure, this and that's their question very often come. If you don't know this relation, simply you will put, I will do the problem, then you will find it very interesting. For time being, you keep it in your mind. Q is equal to minus W for isothermal reversible change equal to P minus P del B, where del B is equal to change of state volume, final volume minus initial volume, and P is external pressure. Think one of the very important part of today's class is spontaneous, and from this I will define what is spontaneity. And very often question asks what is the spontaneity of the reaction. In terms of chemical reaction, there is also some spontaneity, that is called another term is feasibility. If the reaction proceeds from reactant to product, then it is called spontaneous reaction, that is feasible reaction. And if it doesn't proceed, it is non-feasible reaction, non-spontaneous reaction. But here we will term the process, not reaction, whether the process, what are the process in the universe are. There are systems, a lot of processes are going in the system. These processes are spontaneous or not, will define here. It is not only confined to the spontaneity of the reaction, it is the process which one is termed as spontaneous process or which one is non-spontaneous process. So it is a very difficult thing. If you can understand some example, then you can understand. You need not to write any definition, you yourself can write the definition. If you have beforehand the definition, examples of the spontaneous process, then you yourselves can define, you yourselves can understand and write the answer correctly in exam. Let me give first example, mixing of gases. These are the some examples. So far I know I have written some of the example which are termed as spontaneous process. Before giving you the definition, first is mixing of gases. So say you are in this universe, there are a lot of gases are there: carbon dioxide, nitrogen, carbon monoxide, hydrogen, oxygen, helium, neon, argon, krypton, and lots of gases are there. All the gases have been mixed up. There is no interruption or no interference of the human being to get it mixed with other, it automatically mix up. So mixing of gases in this universe is a spontaneous process. Later on I will define. Second one, flowing of heat from the hot reservoir to the cold reservoir. Here two reservoirs, one is hot, another is cold reservoirs, and if it made in inlet to transfer heat from one reservoir to another, so it is naturally it moves from hot to cold reservoir. And this is also a process where no interruption or no interference or no work is to be done by anybody, any person, or from any machine or anything. Hence it is also a spontaneous process. Next is current moves from higher potential to the lower potential, universally true facts. And in a conductor, current moves always there is a potential difference, and when there is a potential difference, one is higher potential, another is a lower potential. Currents of the characteristics of current is that it moves always from higher potential to lower potential. Again, there is no interference or intervention or the work done by any human beings or any person or any agent or a machine to make the current to flow from higher potential to lower potential. Hence, it is a spontaneous process. Next one is the expansion of real gases in vacuum. So a bit earlier I have told you that one chamber to the higher another chamber, it is a big chamber or smaller chamber. If you allow the pass of the gases to in vacuum container, so no work is required, nothing is required, automatically the gas will pass over to this chamber, and the ideal gas expansion in vacuum is called, when it is vacuum there will be expansion, is again a free spontaneous process. Now how can you define the process? So at the fag end, we can define from the inference we derive from all these examples. These are the process where no work is being done on the systems to proceed from one state to another. Hence, all these are the examples of spontaneous process. The process which occurs without any work being done on it is continuous spontaneous process. It is also called feasible process or probable process. So if you think of the reverse of above all this example, mixing of gases, if you want to reverse of this, if you don't want to mix all these gases into constituting gas mixture, you need to do some amount of work which is not allowable, which is forbidden totally. If you still want to make this reverse of these things, you need to do some work outside of the system. You need to some amount of continuous supply of energy from outside the system to make this process reversible. That is called non-spontaneous system. And flowing of heat from hot reservoir to the cold reservoir, if you want to make the flow of the heat from cold reservoir to hot reservoir, it is the against of the spontaneity, law of the spontaneity. If this is forbidden, if you want to make this process reverse of this one, again you need to do some continuous supply of energy from outside of the system to be supplied. You need energy outside of the system to be supplied to make this reverse. So like this and this. So if you want to reverse, so reverse of all these are non-spontaneous process and these are spontaneous process. So this is all about the spontaneous and non-spontaneous process. So I am going to define the entropy. So before defining entropy, let us switch over to second law of thermodynamics. First law is already over. I have talked a lot about the first law of thermodynamics. The U is equal to Q plus W or Q minus W. It depends upon work done on the system by the system. Now it is second law of thermodynamics. There are a lot of statement of second law of thermodynamics, but just here for your convenience, I am writing what Kelvin statement, what Kelvin has proposed or stated. The statement of Kelvin regarding the second law of thermodynamics, that it is impossible to derive continuous supply of work by cooling a body at a temperature lower than that of the coldest COL, lower than that of coldest of the surrounding, means it is a system and this is surrounding. So the surrounding has the last temperature, say 10 degree centigrade temperature is here. So it is not possible to derive temperature to this system, derive temperature to this system by cooling by cooling at a temperature lower than that of this. If you want to derive energy or work by cooling this system by a temperature which is even less than the temperature of this surrounding, which is impossible. This is the statement of Kelvin, and this is second law of thermodynamics. So it is a bit critical to explain or understand. If you deeply follow this one, you can understand the term entropy. So entropy actually it is a state function, means from one state to another. It is designated by S from S2 minus S1. Earlier randomness was described by S1 and finally randomness decreases or increases by S2. So this change of state is equal to del S. So entropy is a state function. It is a state function. Now what is that entropy? It is nothing but the measurement of disorder or randomness of the molecule of the system. In a system, there are a gas molecule. This gas molecules moves in a haphazard way, this way, zigzag fashions. So the randomness of the gas molecule in a systems or anything in this universe, in the spacious universe, the randomness or disorder of the molecule is termed as entropy. Now mathematically, entropy S2 or S final or S initial is equal to del S is equal to dq reversible by time. So mathematically, we can define entropy del S equal to dq by time or q by t. If in mathematically small disorder heat content is there, dq by t, or you can write q by t, S is equal to q by t. Am I right? So dq is the heat content and t is the temperature. Am I right? So entropy del S is equal to dq reversible by t. Now for more elaboration, what entropy signify, to add something more to your knowledge, we need to know the characteristic of entropy. Number one, it is a state function. It on variables. The change of various entropy is dependent upon variable pressure, temperature, volume, number of moles. The change of these factors is brought about in the change in the entropy of a system. Earlier my class I told you what is extensive and intensive property. It is extensive property. It is path independent quantity. Means in which way the change of entropy system one state 1 to state 2, in which way it reach from S to S1, how this change, so how the state S1 to S2, so in which state 1 to S1 to S2 entropy in system 1 is the changes to system 2, the change of entropy S1 and S2 upon the change of these variables, How does it occur? In which path it occurs? It doesn't depend. Hence, it is a state function S1 to S2, does not path function. In which way it occurs, it doesn't depend, and it is path independent quantity. For cyclic process, change of entropy del S equal to 0 means process A, B, C, D, E, F, G, H, I, J, K again A. The process which starts from one state after progressing to different state, it again come back to its initial state is called cyclic. So for this cyclic process, the change S1, S2, S3, S4, S5 actually doesn't mean it is 0. Very important term, very often question of asked, means point number 6, entropy of this universe is equal to entropy change of system plus entropy change of surrounding. So this is a system and this is a surrounding. A part of the universe which is under observation is system, and out of this experimental part whatever remains is called surrounding. Am I right? So there is entropy in the system, there is entropy in the surrounding. So change in the entropy of the system and change in the entropy of the surrounding both combinedly give you the change in entropy of the universe. But for reversible change or reversible process, it is seen the change in entropy of the universe is equal to 0. So if change of the universe entropy S equal to 0, that is del S system is equal to minus del S surrounding. If you put here 0, this equal to minus this, means whatever entropy is gaining in the system, in the same extent entropy is losing by the surrounding, and whatever entropy is losing in the system, decreasing in the system, same amount of decreased of system disorderness will be compensated in the increase of the surrounding. So one is plus, other is minus system surrounding for reversible change. But for irreversible process, del S of universe is not greater than 0, and if greater than 0 means it is something more than 0. If it is something more than 0, that is entropy of this universe means of universe. If it is more than 0, more than 0 means 1 to any term more than 1, that means that system plus surrounding has some value, that means entropy of universe is increasing gradually, where these processes are spontaneous process. All the process of the universe, mixing of gas, whatever is happening in this universe is nothing but a spontaneous process, natural. All natural processes are spontaneous because you can't make an interference, you can't reverse it. Am I right? So the universal process or natural process are spontaneous, and due to this spontaneous process, and this is irreversible process, and for irreversible process it is not 0, it is positive term, and if this term is positive, system plus surrounding has a positive value, means the entropy of the system of the universe is day by day increasing, randomness is increasing, disorderness is increasing. That is, for spontaneous process question arises, the spontaneous process entropy increase or decrease. For spontaneous process entropy increases. So this is all about of today's class regarding thermodynamics, second law of thermodynamics, entropy and spontaneity. Hope you have followed the class with utmost importance, and please don't forget to share and like and subscribe the classes to remain updated, and please follow my continuous class, and in next class I am going to do a lot of important things which is very important for both state board, central board as well as entrance point of view.